Good morning you all. Welcome to the geotechnical classes, and in last 3 classes we covered these all topics that we gone through the syllabus, and after that we studied introduction, earth means what, and definition of soil by experts. Then soil mechanics means what, we studied soil engineering, in that one geotechnical engineering, and scope of geotechnical engineering, where all this geotechnical engineering is used, that we discussed. And origin and soil formation we studied, that is, a soil can be formed, that is originated by weathering of rocks, and that is in two forms, mechanical or chemical weathering, and how that geological process takes place when soil is origin, that is explained, and the difference between residual and or sedimentary and transported soil, and how that occurs, that we studied. Then physical proper weathering, that what all actions will take place in physical weathering, that we studied, and chemical weathering also, that hydration, carbonation, this also we studied. And after that, very important concept, as I said, and this is a three-phase system in soil, and the soil will have a three constituents in it, that is the soil, solids, water and air, and you can represent them in terms of volumes or in terms of weights. And we have a extreme states of soil, that is a dry soil, that will be having solids and air, and we will be having a wet soil, that is your water and solids. And the third one is a unsaturated soil or partially saturated soil or bulk soil. And after that we studied some volume relations. The first one is a voids ratio, second porosity, and the third the relation between the voids ratio and porosity we derived, and degree of saturation definition we gone through, then air content, then the relation between the degree of saturation and air content, this also we studied, that is the relation is S plus AC equal to 1. And after that percentage air voids, the definition we studied. And after that the relation between Na, N and AC we studied, that is Na equal to N into AC, that we studied. And now in this class, till here we studied in the last 3 videos, and now we are entering into the 4th video. We are studying mass of soil. We are studying mass of soil. See, as we already know, that three-phase system means what? It will be having a solids in it, and it will be having a water in it, and it will have air content also. This is called as a three-phase system of soil. And volume relations, you know, volume of air, volume of water, and volume of solids. The same way, when you come to the masses, then you will be having 3 masses here. That is a mass of air, this is mass of air, and this is mass of water, and this is mass of solids, Now out of these 3 masses, this mass of air can be neglected or equal to 0. Actually it is not equal to 0, the air also has its own density, but that density compared to this water and solids, that is very small and neglected. Therefore Ma will not come into picture, therefore we will be having MW and MS only. Means the total mass whatever you measure, the total mass whatever you say soil means, that soil will be having mass of water and mass of solids. These two together it is called as a total mass. Okay, now see here it is written, this is the total mass of the soil, which includes the mass of solids, and water and air. Okay, usually in practical mass of air is neglected, so mass of the soil is the sum of the mass of solids and mass of water. Here the same equation is written here, that is the total M is Ms plus Mw. Hope it is clear, right? Mass of soil, bring some soil means what you will bring? You will bring some soil means you will bring a mass of water and mass of solids, both. Okay, when you bring a dry soil, then you will bring only mass of solids. When you bring a wet soil, then we will bring mass of water and mass of solids. Understood? And here some food for brain, that is what will be the mass of the saturated soil. Just I said now only. Answer this one. What will be the mass of the dry soil? Answer this. In a dry state of soil, whether the mass of the solids and mass of the soil are same. Just check it. Okay, these are just you need to think about that and you need to answer it. Next, coming to weight of soil. See, sometimes we will use mass, the word mass, sometimes we will use weight, but the meaning is same. We are weighing both the things. We are measuring the quantity only, but the meaning is that units are different. See, weight means you are measuring that quantity in terms of kilonewton or in terms of newton. It is somewhat international standard, this one. And in the meanwhile, in international only, the masses when we study, when I call a mass, then I will be studying in terms of kg or gram, kilogram or gram. Okay, this notations I will use. Only unit difference, the quantity will be remains, that measurement of quantity will be remain same. This is the total weight. Here the word is changed, weight of the soil, which includes the weight of the solids of the water, water and air. Usually in practical, weight of the air is neglected. So weight of the soil is sum of the weight of the solids and water. Therefore, W equal to Ws plus Ww. Same thing. Everything whatever that I said here in terms of mass, that I am explaining here in terms of weight. And you should know the relation between how to convert weight to the mass or mass to weight. That you should know 1 kg is equal to 9.81 Newton. By using this conversion, if a weight is given, if you want mass, then you can convert it or vice versa. The same three questions are there with respect to weight, you can answer here. See, now we come to know in three-phase system that in weight relations, the total weight means what we come to know now. We got it. Now, we will define one more term, that is how we defined in volume relations, White's ratio, porosity and all. The same way in masses also we will define one term, that is your water content. And let us consider this is your mass of water and this is your mass of solids. Okay. Now the ratio between these two is nothing but water content. Means what? That is the ratio of mass of water to the mass of solids. It can be expressed in terms of 100. That is in a percentage. Okay. This is the water content. Define water content means what? It is the ratio of mass of water to the mass of solids. Okay. Can be expressed in terms of 100 percentage. Right. Now here the very important question it is asked. Is there any possibility that water content of the soil may exceed 100%? See, here it is expressed in terms of 100%. It doesn't mean that the maximum will be 1. Okay, but in practical, only for this condition, in practical you may have mass of water, huge amount of mass of water, more mass of water, and in a less solids. Okay, a small quantity of soil and you put a large quantity of water in it, then you will get a soil only, that is a mud only. But if you measure the water content of this condition, this mud, then you will definitely have a more than 100% water content. But come to here, that is a degree of saturation expressed in percentage. Percentage here was porosity expressed in percentage, Na expressed in percentage, and AC also expressed in percentage. But these are all expressed in percentage. Here they never exceed 1 or they never exceed 100%. You will not get a S more than 100%, N more than 100%, Na more than 100%, AC more than 100%. You never get it because the equation is like that. But when you come to the water content, here you may expect more than 100% also, because here just they are comparing mass of water and mass of solids. These two are independent variable in the three-phase diagram, but here they depend on numerator and denominator. Therefore here it cannot be exceeded 1 or 100, but in water content it can exceed 1 or 100. Okay, now this you need to remember. And here the weight of water, water content, whatever I said here, that is the mass of water by mass of solids. Even you can write this as a weight of water by weight of solids also. This is also correct in terms of weight, and this is in terms of mass. Both are right. Now, by considering this mass and volume, we will derive some terms here. That term name, first one is a mass density. The first one is what? Mass density. Okay, or simply you can call it as a density only. Okay, only density or mass density, it is a one and the same. Now here it is what? Density is defined as the mass of soil taken to its unit volume. The soil depends on that denoted by rho, it is said. Means just you remember, if I take 1 meter cube of a box with the volume 1 meter cube, means here 1 meter height, 1 meter width, 1 meter breadth. Means every dimension is 1 meter and it's a huge big box. Okay, in this box, how many kg of soil can occupy? How many kg of soil can occupy? Here soil means what? Soil plus water. Okay, mass of soil plus mass of water. Together it is called as a soil. Therefore, in this box, how much kg of soil will be occupied? That is your mass of soil occupied in volume is called as density. Mass of soil occupied in a particular volume is called as a density. Understood? This is the practical application of density. Now here see, it can be denoted as kg of soil can be occupied in a particular meter cube of water. This box. Okay, volume. Or otherwise you can measure in terms of gram and cm cube. Gram and cm cube. And this is it doesn't make any sense that gram per meter cube or kg per centimeter cube, because kg is a bigger unit and centimeter cube is a very small unit. Therefore that is not good to have these two units, and gram is a very small unit and meter cube is a big unit. Therefore again it doesn't make any sense. Therefore you can compare a gram with centimeter cube, that is a good unit, gram per centimeter cube. And if you want, you can compare kg and meter cube. But in soil this also doesn't make any sense, because kg is again a small, again a kg is a small and meter cube is a big. Therefore instead of this one, sometimes we will use tons per meter cube. Yeah, ton is a big unit and meter cube is also big unit. Therefore I can use this one. Okay now. And if you know some unit conversion mechanism, then you can understand that 1 ton per meter cube, 1 ton per meter cube is nothing but 1 gram per centimeter cube. 1 gram per centimeter cube. Okay, just work out this one. 1 ton means how much? 100 kg, 1000 kg. 1 kg means 1000 gram. That you convert here, and meter cube is there and convert it into centimeter cube. Then you will come to know that 1 ton per meter cube equal to 1 gram per centimeter cube. Means centimeter cube is what? A small centimeter cube means it is a small, it is a lid of your water bottle. Okay, water bottle, you know, in that water bottle a box will be there, that lid will be there. That I can say a small, not a big water bottle, just I can say this water bottle. Okay, this is a water bottle, here a small lid is there. This I can say that it is a 1 centimeter cube. It's in a round in shape, but the volume whatever you see, approximately 1 centimeter cube means this much. Okay now, and 1 meter cube means what? 1 meter cube means that I explained here. Where I explained here, that is a box of 1 meter, 1 meter, 1 meter. This is a 1 meter cube. Means when you compare, sir, why it is equal? Because this is measured in ton and this is the gram. See, if a small box, if it take 1.8 gram of soil in centimeter cube, in 1 centimeter cube, means ton, if you say, if I take, then 1.8 tons it will take per meter cube. 1.8 tons it will take per meter cube. Therefore these two one and the same, units are same. Means that numerical value will be same. Understood? This is all about mass or density. And density in sometimes, as I said, this is a gram per kg per meter cube, gram per centimeter cube, gram per centimeter, gram per ton per meter cube can also be used. Okay, now coming to the next, here in this soil mechanics, or otherwise when you are dealing with the soil, depending on the situation, depending on the practical situation, this mass density can be further read as in different terms. We will just simply apply the some prefix, that is a bulk density and dry density and saturated density, submerged density or density of solids. Like that we are using some extra words, that is a prefix words or suffix words, that we are using, and we are pronouncing density clearly with the practical application. Say for example, when I say bulk density means, here I will explain that bulk density of the soil means what? That can be denoted by rho B, bulk density. Bulk means, I already said, bulk means it is a synonyms to wet soil, not saturated soil. Wet means just some amount of moisture is there in that, and bulk it is. And even I can call it as a unsaturated soil. Unsaturated soil. Okay. Unsaturated, instead of unsaturated, we will call it as a partially saturated soil. Partially saturated soil. Partially saturated means little amount of moisture is there. Wet soil means little amount or more amount of moisture is there. And bulk means also the same meaning it gives. Means here the density means you already know, mass by volume. Then what is the meaning of bulk density? Bulk density means you should take here bulk mass. Bulk mass means together it is a mass of water and mass of solids. And that how many volumes how much volume this mass can occupy, that is your V you will substitute here. This is your bulk density. Again the unit and everything will be same, but the meaning of bulk density is here, just here you are using mass, the entire mass of the soil. Okay. Note here the prefix bulk used here says that the soil is in a natural state. Natural state because in natural state some moisture is there, some air content is there, some solids also there. Therefore all three will present in a natural state. In general, soil contains all three phases. Technically, this state of soil is also known as partially saturated soil, moist soil, bulk soil, natural soil, wet soil. These words are very important. Okay. Sometimes if the density is expressed without the use of the word bulk, very important. Sometimes they don't tell you, just they will tell that density of the soil is this much. Density of the soil is 1.8 gram per centimeter cube. They will tell only this much. Now which density it is, whether it is a dry density, bulk density, saturated density, submerged density, density of solids, if that is not mentioned, if any prefix is not mentioned, then it is defaultly you need to assume it as a bulk density. Defaultly you need to assume it as a bulk density. This you should not forget. Understood? Means common name given to the that what density. Now coming to the dry density, what is the meaning of dry density here? Is a dry state of, then mass of the dry soil you are considering, means in a dry state of soil whatever the mass it is there, that will be. Means here mass of water is 0 in this case. Mass of water is 0 in this case. That is your mass of dry to the total volume. The dry density obtained when the soil is in a dry state. It is common sense understood. Now coming to the saturated density. The word here it is used, saturated density of the soil. Okay. Here saturated means what? In three-phase system. In three-phase system, you already know this is a solid state. And if the entire voids are filled by, this is called as voids. If the entire voids are filled by water, then this condition is called as saturated. This condition is called as saturated. Now when this is saturated, and if you measure the entire mass of this one that you put here and compare with its volume, then you will get a saturated density. You will get a saturated density. Okay. Now coming to the submerged density of the soil. Submerged density of the soil is denoted by this one rho dash, or otherwise rho submerged. This also sometimes they will mention. Here you are going to consider submerged weight of the soil and comparing with the total volume, that is the submerged density of the soil. Again, the density is obtained when the soil is its fully submerged state. Means here the water is there and your soil is below the water and it is fully submerged. Okay, now coming to submerged state of the soil, you got the same unit and everything will be same. Next, here we should be somewhat be alert that we are studying density of solids. Density of solids is that you are just only comparing this solid's mass and you are comparing with the solid's volume only. If you concentrate on the previous densities, there the masses were compared with the total volume. Mass of bulk, total volume compared with total volume. Dry mass compared with total volume. Saturated mass compared with total volume. Submerged mass compared with total volume. But when you come to this density of solids, you are getting an idea about only solids, that is the mass of solids to the volume of solids. Okay, the unit and everything will be same, but mass of solids and volume of solids numerator is very important. Okay, then here I will give you, if you know the definitions of these all, then you can surely answer these three questions. That is what is the difference between the density of solids and dry density. Just get the idea, make the sense. Just you can say that, sir, it is a dry mass divided by total volume. This is a mass of solids by volume of solids. You can tell the definition, but make the sense. What is the meaning of dry density and density of solids? Okay, just get this one. And among these, which is greater one, which is always greater than, that you need to recognize. Then the density of solid is always dash than the dry density. Yeah, what? Greater or smaller or equal. Okay, that you need to conclude. Recall the Archimedes principle and explain how this helps in explaining the saturated density and submerged density. In PUC, go and open the science book. There you will get Archimedes principle. Okay, this Archimedes principle, what he says about submerged bodies, that you just recall. And even this one you studied in HHM also. Not only going to the what your previous PVC and PUC and all, just go to the Archimedes principle in submerged bodies in fluid mechanics, that is fluid mechanics 2, hydraulics machines and this one. There also you will get Archimedes principle and get the idea of this one. Okay, now till now we studied bulk density, dry density, saturated density, submerged density and density of solids. Okay, these are things we studied. And here the heading is weight and volume relation. Weight and volume relation is called as unit weight. Unit weight. Unit weight, right? Unit weight is denoted by gamma. Unit weight is denoted by gamma. Then again, bulk unit weight, dry unit weight, then saturated unit weight, then you will have submerged unit weight and unit weight of solids. Then the meaning is same. Here it was a mass of bulk by total volume, mass of dry by total volume, mass of saturated by total volume, and this is a mass of submerged by total volume. This is a mass of solids to the volume of solids. Like that, here when you come to the unit weight, this is a weight of bulk soil divided by total volume, weight of dry soil divided by total volume, and weight of saturated soil by total volume, and weight of submerged soil divided by total volume, and this is a weight of solids to the volume of solids. That I left to you. Just write the definition, how you wrote the definition for densities, the same way you write the definitions for these all things. Okay, this is over. If you have any doubts, you can ask. And after this I will cover one more relation, that is your specific gravity. This specific gravity is very familiar to the civil engineers. They studied since from third semester in BMT lab, and in fluid mechanics we study, in HHM we study, in concrete technology we study, and in future also when you go to the highway materials you study, in geotechnical you study. What is the specific gravity? You should have a very clear idea. Okay, specific gravity means what? It is a comparison of a material to the same volume of water. If I have a one box of some material and the same box of water if I take and I will compare this mass and this mass, then I will come to know that this particular material how many times heavier than water. If a specific gravity is 2.5 means that material is 2.5 times heavier than water. If the specific gravity is 1.8, it says that that material is 1.8 times heavier than water. Then water specific gravity is 1 we will call. Why? Because water is equal to water's weight. Therefore we are comparing with that with the same. Therefore it is 1 only. Okay. And here it is said, hope in earlier semester we got enough knowledge about the term specific gravity. In standard, specific gravity is defined as what? The ratio of mass or weight of substance whose specific gravity is to be determined. Okay, that you need to consider, and to its mass or weight of equal volume of water in standard degree of temperature, that is a 4 degree of temperature. Here in this chapter we are studying the specific gravity of soil. Understood? Therefore this general statement will alter like this, that is, it is the ratio of mass of soil solids to its mass of equal volume of water. In other words, it is the ratio of density or unit weight of soil solids to the density or unit weight of water at saturated degree. Therefore you just remember mass of the soil particles to the mass of the equal volume of water, or density of the solids to the density of the water, unit weight of the solids to the unit weight of the water. I recommend you to remember these two definitions. Okay, just you should remember specific gravity means what? Rho S divided by rho W, or it might be a gamma S divided by gamma W. Over. This only you should remember. That is, the specific gravity is the ratio of density of the solids to the density of water, or unit weight of solids to the unit weight of water. This much is enough for specific gravity. And in geotechnical engineering we define the specific gravity in two different way. That is the true specific gravity. True specific gravity we will call it as a G. Sometimes in textbooks they will write it as a GS. Okay, it is the ratio of density or unit weight of solids to the density of water at standard temperature. Just I defined that one, gamma S by gamma W or rho S by rho W is your G. As I explained in here, the same definition comes to the true specific gravity. Sometimes in hurry or in apparent or in practical cases we will use these words, that is a apparent or mass or bulk specific gravity. Okay, here this meaning is that whatever the density you get it, bulk density, whatever the bulk density you get, and that you are comparing with the water. I already told you that specific gravity means it is a comparison with respect to water. If specific gravity is 1.8 means what? That material is 1.8 times heavier than, water. Understood? Now if I say 2.5 means that material is 2.5 times heavier than water. But that material I am saying, no, what is that material? That material will it will take it as a apparent or bulk or true. Okay, if in this the meaning that material means if I put solids, or if I put bulk soil. If I put that material as a solids, then I will have a definition for true specific gravity. If I put that definition as a bulk soil, then I will have a apparent or mass or bulk specific gravity. Okay, this is just a difference you need to remember, and further definitions and all that difference between the true and apparent, you can go in deep by considering voids. There will be two types of voids, permeable voids and impermeable voids. Okay, that also you can go through, but time being this is enough. Okay, now thank you very much. In the next class we will derive many equations, that is derive the relation between E, G, S and W, and derive the relation between bulk density E, G and S, and derive the relation between dry density E and G, and derive the relation between the bulk density and dry density, relation between dry density Na, W, G, and the relation between E and volumes of two solids. These 5 derivations we will see in the next class. Okay, now till then, bye bye, and make a notes on this one and go on preparing the things. Okay, if you have any doubts, you can put a message. Thank you.